Hey everybody. So back at it again with the circuits problems. I've got two circuits. All right. First is this circuit on the left. Okay. They give you everything. They just say find the output voltage attached across this 60 kilo ohm resistor. Once you've done this, then come over here. Basically, I have the same exact circuit, but I've added a piece to it. So I still have the 120, the 10, and the 60. But then I put an R, all right here in parallel with the 60. And then they say find the output voltage now. All right, so find R. I shouldn't say find the output voltage now. They attach that, and then they say find R such that the output voltage is actually 80 volts. Okay, so we'll do this first, and then we'll do this one second. Okay, so let's get to it. This right here is an exercise in voltage division. Okay. If you recognize a voltage divider circuit, then you are in good standing. If you do not recognize the voltage divider circuit, it's going to take you probably at least 30% longer to get to the end of this problem than it would someone who recognizes the voltage division in this very actively. All right. So remember, the equation for voltage division is V, and I guess I'll just say V2 equals the source times by the resistor of interest. In this case, we'll say R2 over R1 plus R2. And I'll say blah, 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 because this doesn't have to be just two in series. It could be anything. Remember, this is going to follow from the idea that I have resistors in series, all in series with a voltage source. Okay, so if I look and I see that anywhere, or if I see something that looks like it, I can probably finagle it and use this equation to solve or solve for whatever I'm looking for. So if I look at this right here, this first situation, this circuit on the left, I got a voltage source. Current's going to come out from the top. That's just a convention of mine. Current always comes out from the top. It's going to pass through and it's going to go downward like this. All right. Passes through, it's going to go through this one, it's going to go through this one, it's going to come back. This source is in series with this 10, that 10 is in series with the 6, this 60 is in series with the source. They're all in series with each other, all right? And because of that, I want the voltage very specifically on the 60. I'm looking at a 100% voltage divider problem, all right? Once I recognize I can use the voltage divider, I just say, okay, well, V out is attached to my 60. So V out is going to be my VS. VS is 120 times by the resistor of interest. It's attached to the 60, so I'll put 60K right here. All right. Divided by, I only have two resistors right now, so I'm going to do the 60K. And then I just add, actually, you know what? Based on how this is written, I'll go exactly how it's written. The first resistor was 10K. All right. The second resistor is 60K. And that's it. There are no other resistors in there. And this will solve and give me my V out. All right. If you recognize that, then bam, this will be done in like 20 seconds. If you did not recognize that, a lot of people will put these two together, see that this is 70K. They say V equals IR for the 70K. All right, or rather I equals V over R for the 70K. They do 120 over 70. It gives me an I. The I would pass through both of them. So then they'd have to break the resistors back up into 10 and a 60. And then they'd have to say, okay, now for this resistor in particular, 60, I have V equals I times R, where I is 120 over 70. So they're going to get, wow, 120 over 70 times by 60, which is exactly what this is right here. 120 over 70 times by 60. So you could have done that long way, or you could just remember the voltage divider. I recommend learning the voltage divider. You will probably use it on every test you take in your intro to circuits class. Trust me. All right. So I get 120 times 60 over 70. The kilos are going to cancel out. I'm going to end up with 102.857 volts. All right. This is my first answer. Okay, it's just a matter of recognizing that voltage divider. All right, I'm using this first circuit to prepare you for the second circuit. So now we found out, let's come to the second circuit and evaluate what's happening. All right, got the same circuit, but I've attached a resistor in parallel with the 60. If you look at this and call this node A and B, the 60 is between A and B, the R is between A and B. So I know that's in parallel. All right, and they say find R such that V out is 80 volts. Well, if you don't see that it's voltage divider, that's fine. I want you to see that it's still voltage divider. A lot of people are saying, how? This is no longer a series anymore. That's true. But if you think about it, these two resistors right here are in parallel. Okay? And they can be combined into one resistor. That is ugly. They can be combined into one resistor that's between A and B, and then you will have a voltage divider. In other words, this right here can be seen as this. Here and here. Well, this is 10, this is 120. And this right here is now going to be 60 times R, because there are two of them. Let me make it a little bit bigger. Come on. Erase for me. And let's doing that thing where it takes forever. There we go. 60 times R over 60 plus R. That is the equivalent resistance that is sitting right there now. Okay, so 2 became 1. And now I can do that, and the voltage right here is still not lost. Why? Because when you put stuff in parallel, the voltage stays the same. Remember, the voltage is between A and B, so everything that's between A and B gets that same voltage. So when I combine them, it's all good. I still have the voltage divider equation, and I can still solve this bad boy and get an answer. So with that being said, I now have V out. It's fresh. It's not going to be 102 point yada yada anymore, because this is no longer 60. This is some conglomerate mess that I'm looking to get. V out, which was what they told us, is 80. V out is 80. And that equals the source, which is 120, times by the resistor of interest, which is 60 times R over 60 plus R. All right. Divided by 10 plus this right here, 60 times R over 60 plus R. Okay. And I would just solve this for R, and it looks like a mess, but it's not really a mess. What I'm going to do is multiply top and bottom by 60 plus R, and this is effectively multiplying by 1, so I don't have to worry about doing it on the other side. And when I do that, I'm going to have 80 equals the 120 times by 60 times by R divided by another 10 gets us 60, so it's going to be 600 plus 10R, and what I have left is 60R. 80 equals, what I'll do is I'll do a multiplication. I'll multiply this whole bottom piece. I'll bring it over here. So I'm going to have, what is that, 600 times by 80. All right, plus 60 and 10 is going to give me 70. So I'm going to have 70 times by 80 times by R. And that equals now 120 times by 60 times by R. Bring the R over and then divide. So I'm going to have R equals, and it's going to be 600 times by 80 divided by, it's going to be 120 times 60 minus 70 times by 80. And that's going to give me a value of 30. Okay. Now, these were kilo ohms, so this has to be kilo ohms, this has to be kilo ohms, which means my answer is going to be in kilo ohms. I have a bad habit of just neglecting the K, because I know my answer has to also be in K. It's not going to be in K. That's just, that doesn't happen. If it does, then you're doing a weird problem. So I neglected my K's, but good habit would actually be to keep the K's and see how they, cancel and all that jazz. But you're going to end up getting R equals 30K. All right. So I get 30. I'll put a K on the end because I know it's going to be K. All right. This is my second answer, and this is how you handle it. Okay. It's no different. All right. Once you recognize this, the fundamental situation, it's going to, Once you recognize the fundamental situation, then you handle it just like it were fundamental. So once I recognize, oh, I see a voltage division, I see basically what I'm seeing is a parallel connection inside of a voltage division. Once I see that, I draw my voltage division with the parallel connection inside, and I can solve it. All right, pops right on out. You do this, you practice this, and you get good at this, because later on you're going to do this a lot. All right, you're going to have what I call the foresight. You're going to practice enough, you're going to get what I call the foresight. You're going to be able to see the next circuit that's happening, or maybe you're going to see a simpler version of the circuit that you're looking at. When I look at this, I automatically see voltage divider. I don't have to do any reduction, because I know that these two are just seen as one resistor there. So I would have just gone and written this automatically without having to have drawn that. You want to practice to the point where you can see this in your head, and then just draw this out and get to your answer. Okay, so practice makes perfect. Simple voltage divider with a resistor reduction wrapped inside of it, but it's all the same jazz. All right, I hope this helped.